I'm Prasad from Structural Guide. You are welcome to the Structural Guide YouTube channel. Today we are going to discuss about lap lengths. What is lap length? Where we do lapping the reinforcement. What are the different types of slabs? What are the alternatives for laps? All those will be discussed today's video. Please subscribe our YouTube channel. You may get the notification on new videos. Also like us. What is a lap length? Lap length is overlapping two reinforcement bars. That's the simplest way you can tell about lap length. You overlap two reinforcement bars, those overlapping is called the lap. But there are requirements for these laps. Why do we do lapping? Mainly there are two reasons. To curtail the reinforcement, or when we can't continue the reinforcement bar, you can use another bar to continue. For example, now the reinforcement bars has different length. Like maybe based on the availability, there may be different sizes. But generally, you may have a 6 meter bars, 12 meter bars. So if you have 6 meter bars with you, you can't continue the bars beyond the 6 meter. So such a cases you have to need another bar to continue the reinforcement. Those cases we may do the lapping. If the available size is 3 meter, even that case also if you need to continue that bar, you have to have a lap there. So but we have to keep in mind the lap length and the compression or tension anchoring length are not the same. And also special thing you have to keep in mind when you do lapping as a general norm or as the requirement, we do lap based on the smaller bar diameter. Lap length is equal to factor. We will discuss about this factor later. Factor into D2. D2 is the smaller bar diameter. That's what we consider lapping in the reinforcement. Type of slabs. There are mainly two types of slabs. Tension laps, compression laps. Laps you do at the tension zone, we call the tension laps. Lap we do at the compression zone, called the compression laps. Their properties are different. Their zones are different. So the parameters or the factor considered in each zone is not the same. So as I explained previously also, we don't want to continue the same bar throughout the beam. The tension reinforcement requirement is high at the supports. Yes. You may provide the higher reinforcement area here. For example, you may provide 3 numbers of 20 bars here. But in the midspan, you don't want that much of reinforcement. So in those cases, you may provide a small area or the minimum requirement. For example, say we provide only 3 numbers of 16 bars there. So here 3 numbers 16 bars. So here 25 bars there. 3 numbers of 20 bars. So this has to be converted. Now 20 bar stress need to transfer to 16 millimeter bar. So this position is the changing point. This position is the called the lap length. This termination or the termination of the 25 millimeter bar here will be done based on the curtailment requirement. There are different curtailment requirements, so that we have to consider. We are not going to discuss the curtailment requirement here, but we have to consider the curtailment requirement. In simple terms, the no longer required point we have to find, and then we have to terminate the lap. In the compression zone also the criteria is same. Tension lap length. Lap provided in the tension zone of the beam are called the tension laps. It's depend on the smaller bar diameter as I explained. Also it depend on the reinforcement bar type. There are different types of reinforcement, so bar type is also need to consider. Reinforcement bar material safety factors. There are different material safety factors. They also need to consider when determining the lap length. In addition, the element sizes or the cover to the reinforcement, the gap between reinforcement, all those need to consider when you determining the lap length. Those we have to keep in mind are the as the factors related to the lap length. Tension length of the reinforcement bar. Let's see how to calculate that. So I have written the equation here. So according to this equation you have seen here, there are three things. D is the smaller bar diameter at the lap. F is a factor depend on the concrete grade. So we have to consider the concrete grade. With the concrete grade, this factor is varied. Higher the concrete grade, smaller this factor, smaller the factor. You can reduce this factor when the grade is increases, because we can have higher bonding strength when you increase the concrete grade. A is factor depending on the cover or the reinforcement bar spacing. So these two factors, factor F is you can obtain according to the BS 8110. You can refer the table 3.27 to obtain this factor. But depending on your code, that may be different. So the A factor also you can refer clause 3, 12, 8, 13 in BS 8110 for the information. However, now if you might using a different standard, so according to your standard, these two factors may be not the same. There may not be factors like this. Maybe a single factor may be there. There may be many factors other than two. So those has to be considered depending on your code. Tension laps in walls and raft foundations. Slabs. On those slabs, this factor, say here I can show here 1.4. This factor depending on the bar spacing, bar diameter, the cover to the reinforcement might be 1, might be 1.4, it might be 2. So in most of the time slabs, walls and foundations, this requirement is not violated. The requirement is specified in the clause 3.1, 3.12, 8.30. In such cases, the factor may be 1. So therefore, you can see here in the equation, F into D you can consider. So for example, grade 25 concrete, you can see here factor is 44, bar diameter say 20, so the lap length is 880. That way you can calculate the tension lap length. Compression lap length. As I mentioned previously also, compression lap is the lap we provide at the compression zone. It's depend on the smaller bar diameter, reinforcement bar type and material set factors. This lap also same as the tension lap, but this factor if it's not the same as the tension lap. Sometimes the tension lap and the compression lap, this factor is same, but some occasions these factors are not the same. So you have to consider depending on the requirement or depending on the grade and reinforcement type, etc. You have to consider this factor for compression lap, that you have to consider, and then you have to multiply it by bar diameter. Alternatives for reinforcement lapping. So we use the mechanical couplers instead of lapping in the construction, especially in concrete columns. If you have so many bars there, if you have a laps, the reinforcement congestion will be increases. Forming honeycombs, improper concreting, poor compaction will be there. As a measure to that, we use couplers. We may use combination of those, that is couplers and combined with the laps both. So some sort of bars, I mean, say 50% of bars we use couplers, 50% of bars use lapping. In addition, you can do the staggering of the reinforcement laps. So You can do the couplers and lapping stagger away, and also you can mix it so that the congestion can be reduced. There are different methods to use the couplers. So as you can see in this figure, also you can cut the threads in the reinforcement. You can cut the thread, then you can fix that item like this. You can see here, this is the coupler. You cut the thread in the rebar either side, you can fix it to by this coupler, or else you can keep the reinforcement as it is like this. You may use the wedge like this. This is mostly used for the paint bars. You can use this, and also you can, with the high pressure, you can fix this. There are there are two methods. You cut the threads on the rebar, or else you can fix the coupler without the rebar threading. So, and in those cases, if you don't cut the threads, you have to press it mechanically until its bonding is achieved. With that, you can do the coupling. So that's the best alternative be available in construction to replace the laps. With that, we end today's discussion. So today we discuss about laps. Where to lap? What are the different type of laps? What are the alternatives for laps? Let's meet again for new video. Thank you very much.